I'm Clark Bendel. I'm a principal engineer with Waygate Technologies. The imaging system on the Everest Mentor Flex is really taken from our high-end Mentor Visual IQ product that has been highly regarded for its image quality in the high-end market for several years now. So these two products share the same, optics, the same sensors, the same guts of the insertion tube. We've taken the image signal processing from the Mentor Visual IQ, and we ported that over to the computing platform in the Everest Mentor Flex. So in many ways, you're getting the same kind of image quality on this product as you would have in our high-end Mentor Visual IQ product. So one great image processing feature that we will have on the Mentor Flex, which is something we also offer on the Mentor Visual IQ, is what we call dark boost. So this is a processing function that will intelligently evaluate the contents of the scene. And if it's a low contrast scene that's going to look good without any additional processing, the dark boost processing doesn't kick in. But when you get into a scene where you have a lot of darkish areas in the scene, possibly along with some glare, which you can often get when you're inspecting shiny surface objects like compressor blades in a turbine or high purity tubing with welds, etc. By using that dark boost function, you can lighten the areas that are otherwise quite dark and difficult to see without overly brightening the brighter areas. So especially for shiny surface type inspection, dark boost can be a really useful feature, and it's something that we do not have on our prior XL Go, XL View, XL Flex and Detect products. So this is a new feature for this tier of product. So another great thing about the Everest Mentor Flex is it carries over the light engine from the Mentor Visual IQ. So this is a very high-powered LED that's efficiently coupled to the fiber bundle and really gives us a ton of light coming out the end of the probe. So what this allows us to do is, obviously, with a given set of optics, you can see farther than you can with less light output. Or you can have an optic that has, say, a smaller aperture, which gives you a larger depth of field. That's the distance from the nearest in-focus point to the farthest in-focus point. And so by having that small aperture, you can see over a larger range of distances and still have sufficient brightness. Whereas if you have less light output, your far viewing distance would be limited with those smaller aperture tips. And sometimes those can be really useful in an application where you are scanning for an indication at a farther distance, and then you want to push in closer to be able to really assess what you might have seen. So highlight output can really help improve efficiency and detection in a lot of applications.